Hello YouTubers, Tross here, and this is just a quick video to show a game I made in Shenzhen I. I had a little quick look at this game. I did the first few puzzles, and maybe about a third of the way in you get this prototyping new ideas, which they basically say, hey, I'm gonna give you access to everything in the game. Well, when I first got to it, it wasn't everything in the game. It was everything that was unlocked to that point. Since then, everything unlocks basically before here. They just say, certain things you won't be needing yet. Anyway, custom LCDs, basically everything in the game. And hey, we can make retro-style handheld games. And basically, that's your objective. So I had a few different ideas. And this is the first one that I actually, went to completion with, basically. So let's open it up. I call this Maze Master. And it's pretty complex. But these three chips and this one together generate a maze. And then these three chips... processors together let you move and play through the maze, and when you win, this one is activated that plays a little tune. So let's simulate that. This is a game controller. It looked nicer previously, but it also took up more room. It was set up kind of like a D-pad with WASD, and originally I think it was IJK and Enter. Enter was supposed to be like your start button. Enter was positioned centrally, IJK, and then WASD in D-pad. But they made it smaller. It was basically, I don't know if it was 1 or 2 spots bigger. They made it smaller so you could fit more stuff on your board. And as you can see, I've pretty much filled this board. It's probably not the most efficient game or way to do this. Here you go. I'm going to use WASD to move around. This actually turns out to be pretty simple. If you try to go out of bounds, like I'll press down here, you get a little beep. Press left. If you try to go out of bounds, up. It does seem to cache your key presses a little bit. And that's it. I won. Very simple, but every time you run it, if I hit reset and simulate, you get a different maze every time because I'm using this random signal generator. Let's try that again. All these mazes are what's known as binary tree mazes. Basically, you leave the top and the left. Oh, that's how I'm doing it. I guess you could do any two sides, but you leave those clear. And then each cell, or each 2x2 4-block cell, you always fill in the top left. You always leave the bottom right clear. And then you randomly pick one of the top right or bottom left to open up. And it's basically every node if you think of it as this is the root of a binary tree, you fill in the whole right side and whole left side, and then for each internal node, you randomly pick it being connected to the node above and to the right, or above and to the left. Above and to the right, or above and to the left of it. If this was the root and this is the bottom of the tree, and then you randomly pick one of the final leaf nodes to be the exit. In my case, I am only picking exits along the bottom. You could also do exits along the right, but as I have an extra space, at least in the normal standard matrix, that's what I did. And so this is a simple game. I'm using the standard matrix 10 by 12 row matrix that comes with the game. But I thought, what was the fun in that? It's a simple maze. So I made the Mega Maze. It actually says 18 parts. I'm guessing that's counting jumpers as parts, because it really only has one additional part. Here is the additional part. I moved this a little around, and I try to re-snake wires. Here's the connection. It's basically the same. Let me see, these are just connected simply. The only complex connections you don't see are this here, just because I turned this around to make it easier to access. This is going over to X2 here, and this guy through X2 connects to D0. It's passing through X1. Actually, I can go like that because it's not actually using X1. And it's basically the same thing. A little different in, it's hard to see, but now this is a 30 by 32 matrix. And we have, one is the outline. It's basically the top, the left, and this edge around the bottom. And there's actually a line connecting up here. I had a hard time getting this to be number 1. Originally it was coming out before this first row, or last row, and throwing everything off because I kind of need, the way the algorithm works, all these numbers to be sequential. But eventually I did something, I don't know what exactly, but I got all I got it to be number 1. I'm guessing it puts the number in the center somewhere, so you can't read any of the numbers, at least on my screen. Add a little wind indicator down here, so there's some code differences for that. Yeah, basically this is same thing. This turns on the edge. It basically turns on one. It turns on all the ones on the right edge. It turns all the ones on the bottom edge on. Then it kills itself. It basically waits here. I should put a halt there because that's what it does. It gets triggered at once. It will never get triggered again. So it's basically infinite sleep. This is the start guy. Everybody else starts off in a sleep state. He triggers this guy, and then basically for starting at 33. Which skips the first row here, and then skips the first dot in this first column. He goes and sends every other number. Basically, it starts off 33. He sends to this guy, which generates that cell. All the cells, it's a 2 by 2, and it's always... the second row is always 30 more than the number that was passed in, and it takes a reading off of P1 from the random. That's why I have sleeps, to make sure the random guy changes. I don't think it changes if you don't sleep. Didn't really test that. So I'm not using this memory cell, except, well, I am. There's a 1 here. Basically, this is... there are 14 2x2 cells, and leaving a gap for the row here at the beginning, and the solid wall at the edge. This, 28, and then 29 and 30. And basically, I just read, and when I see a 1, I know I'm at the end of a row, so I add 32 to the current value to get to the next row. And that's how that works for generating all of this. Once we reach 930, we know we're done, so then we signal this guy to put in a hole at the bottom. Basically, he picks one of the 10 last cells, so he's not going to be in the first 5 rows, the exit. 5 columns, not rows. And basically the rest of it's the same, except once we get the win condition, this guy sleeps then for the win condition in addition to this guy. Luckily, it worked out that he picks up the actual value. He just wakes up and doesn't see the value. He plays a little tune. He toggles win on and off indefinitely then. So let's play this one. Takes a bit longer to generate the maze. I can actually put the speed up. But this is much more maze-like mazes. It's still not every possible maze. You'll never have to go right and then back to the left. You'll always only go right or down, but it's still a lot of hallways. Again, it still beeps. In fact, I had to change a little bit of the code since there's no actual dots at the top. Of course, going faster makes the tune go faster. Let me adjust the tune a little bit. So, in the original version, there were actually dots up at the top. Basically, the way the movement works is, which I didn't explain, basically the same for each. This guy remembers your position and he blinks it on and off. He sends your position over here. He asks, well, what was pressed? Basically, sends the number over and either adds 1 or subtracts 1 if you're going left or right, or adds 30 or subtracts 30 if you're going up and down, sends it back. This is one change, is he originally just asked the display, hey, is that cell currently on? And if so, send back the same position that you were originally in and play the buzzer. Otherwise, send back the new position, and then he would blink on and off the new position. The addition now is there's no actual real cells above you, so I check it to see if it's less than 2, and if it is less than 2, like pressing up from here, it beeps at you. You can see it quickly flashes negative 28. Otherwise, everything works as previous. Let's solve this. There we go. Even now, up to the highest speed, tune sounds a little better than it did before. So, that is my game. One of the things I was thinking of, but I'm not going to attempt, but I'll let someone else try it. I think you can do Conway's Game of Life either using 2 displays, and as I'm doing here, using the display as memory. Basically 2 displays, because you need a current generation to read from and a new generation to set to. So you'd actually have basically 2 copies of the logic. One would run, take the current state, make a new state on the second display, and that would then trigger the second version to then take that and calculate the next generation back on the original display and trigger the first set again, over and over and over again. You could probably also implement touchscreen, which I didn't do, to set the initial state. That could use then a higher density matrix if you did it like that. If you didn't want to use a higher density matrix, let's go back to you. Well, this one I was actually thinking of doing breakout on. So it just does that for now. Let's pull out a memory RAM. I think you could do Conway's game of life with one display and 2 sets of RAM. Basically, you got 12 rows here, and this has 14 memory slots. I think you could actually have a single memory slot remember the on and off states of a whole row. If you know anything about binary, 8 bits is a byte. You can get that's up to 255. These can hold up to 999. Well, that will get you another bit with a 512, but you're short the last cell. But you actually have negative 999 to positive 999, so the sign can actually act as a bit. So you would need something, a decoder of sorts that would be able to read a number from here from negative 511 or negative 512 to 511, and that would give you a whole row of lights. You need then some logic to be able to ask the state of various. Basically, you need a reader and a coder and decoder. They could be connected up to the 2 sides. Then a chip that would go and basically ask, all right, what's the values of each of one's neighbors? Figure out what one should be, and basically you'd have two of these, current generation, next generation. You'd figure it out, and then, one at a time, iterate through, copy from the current generation to the new generation, then display the new generation and copy the state back to the previous one and go again. I think that's doable. I'm not sure how. It would be the coder and decoder is the hardest part. I'm not sure that would fit into 15 commands. But if someone wants to try it, it's probably doable. So, that's this video, I think. Basically, I'm just actually surprised myself that I was able to fit the maze generation in here. Although, I shouldn't be too surprised because I actually basically wrote this algorithm in Minecraft using redstone and command blocks to generate a maze. You can look at one of my previous videos. Actually, it was called Aperture Maze minigame, I think it was called. So, thanks for watching. And I'll see you guys next time.